All right, in this video we're going to take a look at some properties of logarithms. So the first one here is log with base a of 1, indicating that the base could be anything and this property will still hold. Log of base a of 1 is equal to 0 because if you take a and raise it to the power of 0, anything to the 0 is equal to 1. So log base a, any base of 1 will always equal 0. The second one here, log base a of a, is equal to 1 because we're looking for a to what power equals a, and it would be a to the first power will equal a. And here notice we have a base and then the argument is a, that same base to the power of x. This is just equal to x because we're looking for a to some power, let's say y, I'm trying to figure out what it is equal to the argument of a to the x. And since if a to the y is equal to a to the x, then we know that x is equal to y, or y is equal to x, I mean, and so the answer to this would just be x. The next one is if you have two logarithms with the same base, and it could be any base, but it has to be the same. If those two logarithms are equal, then we know that the arguments also have to be equal, so x is equal to y. And you can go vice versa. If x equals y, then you can take the log of both sides of any base, and it'll still remain equal. So on the right side here, evaluating some logarithms, pause the video and calculate those, and then come back and check to see if you're doing those correctly. So log base 5 of 1 is an example of the first property here. It will equal 0 because we're looking for 5 to what power equals 1, and it's 5 to the 0 to get 1. Log base 6 of 6 is 1 because 6 to the first is 1. The next one is the same base of 2, and then 2 to the 4th is equal to 4 because 2 to the 4th would equal 2 to the 4th. And then if you have a log of 7 is equal log of x, which both of those have base 10, we know that this must equal this, so x is equal to 7. Okay, so the next set of properties, previous set was coming from lesson 3.2. This next set is coming from 3.3, some additional properties of logarithms, page 203 to 206 in your textbook. First thing we're going to look at is the change of base formula. In the previous video, we talked about how your calculator only has base 10 and base e, so you can only evaluate logarithms with those two bases. But there is a very simple formula for changing any base to base 10 or to base e to use your calculator. And you can change it to any base. It doesn't have to be 10 or e. Those are just most commonly what we want to change to because that's what we can evaluate with our calculator. So if you have a log of any base, base a of x, you can convert it to any base. What you do is you take the log of any base that you want of the argument, which is x in this case, and you divide by the log of that same base of this base. So this base goes here, and the x, the argument, goes here. So if you convert that to base 10, it would be log of x over log of a. We don't write the base when its base is 10. Or you can convert it to base e and have natural log of x over natural log of a. All right, so let's look at how to use this. So if we want to find log of base 5 of 12, what we're looking for is 5 to some power, that's what we're looking for, is what power is equal to 12. Remember that a logarithm is equal to an exponent. So we could try different numbers. If you put 1 in for x, 5 to the first is 5. If we put 2 in for x, well, let's do this. 5 to the first is 5. 5 to the second is 25. And since 12 is in between 5 and 25, we know that my answer the answer that we get should be somewhere between 1 and 2, because it's going to be an exponent that's going to be more than 1 but less than 2, because 1 gives us too small of an answer, an exponent of 2 gives us too big of an answer. So that's kind of where you can like make sure that you're doing things, just check the reasoning. Does it seem like it should be correct when you do this? Okay, so let's convert this to base 10. So so we'd have log of 12 divided by log of 5. And now to evaluate this, we need a calculator. All right, so I have my calculator, and I am going to punch in log of 12 divided by log of 5. So here's the log button. It's row, get my cursor here, down here. This is row 0, we call that the graphing row. 1, 2, 3, 4, 5, 6. Row 6, column 1, you've got log, that's your log button. Right below it is ln, so if your base is e, you're going to use this button. If your base is 10, you're going to use this key. So we're going to type in log of 12, and here's something you got to really pay attention to. You need to end the parentheses there, because that's the end of the argument. And then we're going to divide that by log of 5, and when you hit enter, you get 1.54395. So what we just found is the answer to this question right here, 5 to what power is equal to 12. And so if you go into your calculator to check the result, we can take 5 and raise it to that answer, 1.5439. You can round it and you'll get approximately 12, or you can hit second answer, you take that whole thing and you'll get exactly 12. Okay, so you can also do that same thing with natural log. If I type in natural log of 12 divided by natural log of 5, we get the exact same result. So either one, but you just have to make sure that if it's log on the top, it's log on the bottom, base 10. And if it's natural log, that you use natural log over natural log. Okay, so that was approximately, what was it, 1.544. We'll round to thousands place. 1.5, and I should put approximately 44. So why don't you go ahead and evaluate log of base 3 of 97, and then check your work with me. So we're going to take the log of 97, or natural log, over log of 3, put that in the calculator. Log, I'm going to go ln of 97 over ln of 3. Even though I wrote log, I can still do this. It's still going to give me the same answer. 4.164 is about correct. That's rounding it. And if I take 3 and raise it to that power, I get exactly 97. So again, check this out. Log of 97 with base 10 divided by log of 3 base 10 is also going to give us 4.164, roughly. Okay, so let's look at a couple of additional properties: the product property, the quotient property, and the power property. So the product property is when you have a log with a product, you can rewrite this as the log of base A of u plus log base A of the second factor b. So for example, if you had ln of 3x, our base is e, so we can split this up, and sometimes you may want to do this, and sometimes you might want to go in the reverse and put it together as a product. So the natural log of 3, if I use the product property, plus the natural log of x is equivalent to ln of 3 times x. And ln of 3 we could evaluate with a calculator. You just type in ln of 3 and it'll give you the answer e to what power equals 3. It should be just a little bit more than 1 because e is a number really close to 3. So you can check that out if you want to. The quotient property. If you have a quotient instead of a product, then you change this to log of base A of u minus log of base A of the denominator b. So with a product, You can split it up into 2 logarithms added together, a quotient, 2 logarithms subtracted. You subtract the denominator, the log with that base with the denominator. So for example, ln of 1/2 can be simplified to ln of 1 minus ln of 2. And what is ln of 1? Remember from before, we had e to what power equals 1? Well, this e to the 0 is equal to 1. So this part right here is equal to 0. So this answer could be written, you can write ln of 1/2, and it is equivalent to negative ln of 2. Okay, then the next property is the power property. When you have a base and an argument raised to a power, you can drop that power down in front. And this is a very powerful, no pun intended, but property. So bring that n down, and this is going to help us when we're trying to solve for exponents. This property is used quite a lot. So you can bring this, you can drop that exponent down in front, and then this argument would just be what's left, which is log base a of u. So if you wanted to evaluate ln of e squared, we can apply the power property, bring the 2, the exponent, down in the front, 2 times ln of e, and then think about what ln of e is. Ln of e has a base of e to what power equals e? Well, e to the first would equal e, so this equals 1, so we have 2 times 1, which is 2. So ln of e squared simplifies to 2. All right, I'm going to stop there.